Black holes, cosmic enigmas, points of infinite density and gravity so intense that not even light can escape. Often imagined as silent, invisible predators lurking in the dark, black holes are also, sometimes, cosmic wanderers, moving through the vast stellar cities we call galaxies. While many black holes are born in place, remnants of dying stars, or the colossal giants at galactic centers, others travel, plowing through the stars, gas, and dust of their cosmic neighborhoods. What happens when a black hole moves through a galaxy? What trails does it leave behind? And how does its journey shape the stars, the gas, and the very evolution of that galaxy? Join us as we unveil the remarkable story of black holes in motion, cosmic nomads carving trails across the universe. The nature of black holes, from birth to motion. A black hole begins its life in catastrophe, the death of a massive star, collapsing under its own weight, or the merging of neutron stars. At the centers of galaxies, supermassive black holes, millions or billions of times the mass of our Sun, anchor the galactic core. But not all black holes remain fixed. Some are ejected from their birthplaces by gravitational interactions, recoil from asymmetric supernova explosions, or the gravitational waves emitted during mergers of black holes or neutron stars. These rogue black holes can be kicked out at speeds ranging from hundreds to thousands of kilometers per second, setting them on a solitary journey through their host galaxy, or even into intergalactic space. A black hole's journey through a galaxy. Imagine a black hole moving through the dense stellar fields of a galaxy, a cosmic bullet hurtling through a crowd of stars and clouds of gas. Its gravity tugs on nearby stars and gas, disturbing their orbits and creating ripples of chaos. As it travels, it can accrete gas, pulling it inward to form a glowing accretion disk, a brilliant beacon in the darkness. But more than that, the black hole carves a physical and energetic trail. The gas it encounters is compressed and heated, creating shock waves and wakes of ionized plasma. Jets of high-energy particles may blast from its poles, driven by magnetic fields swirling with the accreted matter. In some cases, the black hole's path can trigger star formation, compressing gas clouds into newborn stars, a cosmic garden blooming in the wake of destruction. Detecting the trail, from X-rays to radio waves. While black holes themselves emit no light, their interactions with surrounding matter shine brilliantly. X-ray telescopes detect the hot accretion disks where gas reaches millions of degrees. Radio telescopes pick up jets, streams of particles traveling near the speed of light, emitting synchrotron radiation. Optical telescopes observe shock waves illuminating gas clouds and star-forming regions. Together, these observations reveal the invisible path, the trail left behind by a black hole's passage. The wake of a cosmic bulldozer. Like a bulldozer clearing a forest, a moving black hole reshapes its environment. Stars near its path may be flung into new orbits or even ejected from the galaxy. Gas clouds may be stripped, heated, or compressed. The black hole's wake can extend for thousands of light years, a vast, turbulent region glowing with energy. This wake is a record of the black hole's passage, a cosmic fingerprint etched into the structure of the galaxy itself. Impact on galactic evolution. The wandering black hole is more than a solitary traveler. It is a catalyst of change. Its trail can regulate star formation, suppressing it in some regions by heating gas, while triggering it in others by compression. It can stir the galactic disk, redistributing gas and stars. Over millions of years, these interactions influence the shape, brightness, and chemistry of the galaxy. In some cases, the black hole's journey may contribute to the growth of supermassive black holes at the galactic center, feeding them with gas and stars pulled from the wake. To truly grasp the trail a black hole leaves, we must peer into the physics of its passage. Gravity's grip, tidal forces, and stellar encounters. The black hole's gravity is a relentless force. As it passes near stars, it exerts tidal forces, stretching and squeezing, sometimes tearing them apart in spectacular tidal disruption events. These events unleash bursts of light across the electromagnetic spectrum, briefly revealing the black hole's presence. Stars that survive may be thrown onto new orbits or ejected entirely from the galaxy, becoming hypervelocity stars, cosmic castaways racing through intergalactic space. Accretion and energy release. Gas clouds drawn into the black hole form accretion disks, swirling faster and heating to millions of degrees. Friction and magnetic forces within the disk generate intense radiation, from X-rays to gamma rays. The black hole converts mass into energy with staggering efficiency, powering jets that pierce through the galactic medium. These jets inject energy far beyond the black hole's immediate vicinity, stirring the galactic environment. The shockwave, a trail of light and heat. The passage of the black hole creates shockwaves in the interstellar medium. Gas compressed and heated emits light, from glowing hydrogen clouds to ionized metals. These shockwaves can trigger the collapse of gas clouds, sparking new star formation. In this way, the black hole's destructive power also becomes a creative force. Magnetic fields and cosmic rays. The accretion process twists magnetic fields, launching jets of charged particles. These cosmic rays travel far, influencing the chemistry of gas clouds and affecting the conditions for life. The magnetic fields also sculpt the shape and reach of the black hole's trail, creating spectacular cosmic structures. For humanity, observing a black hole plowing through a galaxy is both a scientific triumph and a humbling reminder of our place in the cosmos. Observing the unseen, technology, and challenges. Detecting moving black holes is a challenge. Their invisible nature means we rely on indirect evidence, bright accretion disks, unusual star motions, and energetic jets. Advances in telescopes across the electromagnetic spectrum have opened new windows. From the Chandra X-ray Observatory to the Event Horizon Telescope, we are beginning to map these cosmic wanderers and their trails. Philosophical reflections, order, chaos, and cosmic dance. The black hole's journey embodies the duality of the universe, destruction and creation, chaos and order. As it carves a path, it destroys some stars, births new ones, and reshapes galactic structure. This cosmic dance reflects the ever-changing nature of the universe, a dynamic interplay of forces shaping the grand tapestry of existence. The future of study, unlocking galactic secrets. Future missions and observations promise deeper insights. Simulations combined with observations will unravel the complex interactions of black holes in motion. Understanding their trails helps us decode the history of galaxies, the growth of black holes, and the evolution of cosmic structures. To truly comprehend the cosmic spectacle of a black hole moving through a galaxy, we must journey deeper into the intricate physics governing its motion and the cascading effects on its surroundings. The galaxy itself is a complex system, billions of stars, swirling gas, magnetic fields, and dark matter, all bound by gravity in a vast, rotating dance. When a black hole intrudes into this grand choreography, it disturbs the balance, creating waves of change that ripple across millions of light years. Gravitational drag, the black hole's invisible hand. As the black hole travels, it does not simply glide through empty space. Instead, it experiences a gravitational drag, a phenomenon known as dynamical friction. The black hole's gravity pulls nearby stars and gas toward it, creating an overdense region or wake behind it. This gravitational wake, composed of stars and gas clumped slightly out of alignment with the black hole's path, exerts a pull on the black hole itself, slowing it down over time. This drag not only governs how far the black hole travels before it sinks back toward the galactic center, but also sculpts the environment it moves through, leaving behind a distorted trail.